In the first video, we've checked the difference between experimental probability and theoretical probability. Let's revise that again. So experimental probability and theoretical probability. Okay. The experimental probability, we've seen that in topic A and B. So that is by observing the results of an experiment. While for the theoretical probability, we use arguments of symmetry. So by using of symmetry. And this video is about the theoretical probability. If a sample space has n outcomes which are equally likely to occur when the experiment is performed once, then each outcome has probability 1 over n of occurring. So for example, when we roll a dice, we have 6 possible outcomes. 1, 2, 3, 4, 5, and 6. Okay, this is my sample space. So I have 6 possible outcomes. And the probability of, for example, the outcome 3 is equal to 1 over n, and n is in this case 6, so it's 1 over 6. So the probability of occurring 3 is 1 over 6. But also the probability of the outcome 4 is also 1 over 6. And the probability of the outcome 6 is also 1 over 6. Okay. An event occurs when we obtain an outcome with a particular property or a feature. When the outcomes of an experiment are equally likely, like you can see here, the probability of an event E occurring is given by the number of outcomes corresponding to E divided by the number of outcomes in the sample space. Okay, let's make some examples, then it's gonna be clear. Let's go to example 6 in the book. So, suppose 3 coins are tossed simultaneously. Find the probability of getting 3 heads. And now for B, we have to find the probability of getting at least 1 head. Let's first check the possible outcomes. Let's say that capital letter H is equal to head and the capital letter T is equal to tail. Okay, then we can say that the possible outcomes are, because we throw 3 times, so we can have head, a head, a head. We can have 2 heads first and then a tail, or we can have a head, tail, head, or we can have a head, tail, tail. Okay, let's start this time with the tail. So we can have a tail, head, head, tail, head, tail, 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 head, or we can have a tail, tail, tail. 1, 2, 3, 4, 5, 6, 7, 8. So we have in total 8 possible outcomes in the sample space. So 8 possible outcomes, or 8 outcomes in the sample space. If we go to A, there we have to find the probability of getting 3 heads. So 3 heads, the only possible outcome is H, 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 like 3 times head. So there is just one possible outcome. So we can say that the probability of getting 3 heads is equal to this one possible outcome divided by the number of outcomes in the sample space, so the 8. And let's go to B. And there we have to find the probability of getting at least one head. So at least one head is actually everything except the tail, tail, tail. So we have 7 possible outcomes. 7 possible outcomes. So the probability of getting at least one head is equal to the 7 possible outcomes divided by the number of outcomes in the sample space, which is equal to the 8 here. The answer is here 7/8.